Enter and leave CPU commands allow us to facilitate construction of the procedure stack frame, and also removal of the procedure stack frame from the stack. So basically, let's just walk through a series of demonstrations right here on the slide by using our call into add three numbers procedure, which basically finds some parameters already present on the stack, adds them together, and returns result in EAX. So let's just assume that we have some sort of initial state of the stack, and we have our register ESP pointing to the top of the stack. What is below this ESP in higher addresses, basically in this stack segment, we don't care. This memory does not belong to us. It's something already preserved on the stack by the callers of our procedure. So we just generally expect to use the upper portion of the stack, or basically going in the direction of the lower memory addresses in the stack memory segment. So this is some sort of initial state of the stack, and then procedure parameters are pushed on the stack. So this is step number one right here, right? So this is, if this is 1, it's this. Okay, so we're starting to push some parameters on the stack because we know this procedure is expecting these parameters. So now these parameters, 10, 20, and 30 hexadecimal, in our case, these are integers, 4-byte size, or double words. And so this is where they are, right? So this is the parameters that we already pushed on the stack, right here. So these are our parameters. Now the stack pointer, of course, pointing to the last parameter that we pushed. Basically, ESP at this stage is pointing to this number on the stack, right here. Then we call the procedure, which is of course the call instruction, transferring control to the memory address of our procedure, but call automatically preserves the return address, which is the address of the next instruction right here. So the address of this instruction is saved on the stack, so that when we say a return, we will be jumping back to this instruction. So now we're here, we have our return address already on the stack. And now, of course, the stack pointer is pointing to the return address. Then we move our typical push EBP, move EBP, ESP commands to that we call procedure prologue right here, right? So these two instructions. So this is what we're doing next. So the outcome of executing this prologue, right, will be here if I just number it number 2 over here, right? So this would be number 2. And so the result of this is that new element on the stack is register EBP, which we simply preserve. We want to preserve this register not named stack frame base pointer. We want to preserve its value, and we continue to use the stack to preserve things. So now both ESP and EBP, because they're now set equal, they're pointing to this old EBP. And that's what this demonstrates. So after this, just as we begin to do some work in our procedure, we have this state of the stack. But then, supposedly, we would like to organize it in such a way that maybe we want to use some local variables inside this procedure. And local variables reside not in the global data memory segment, but we want them to reside on the stack. So the idea is now to organize space for local variables. And so what we need to do is to grow the stack by a specific number of bytes to allocate space, so that we move essentially from this position pointing to EBP, we want to move ESP a little bit upwards into the direction of lower addresses, in our stack memory segment so that we create more space on the stack for our local variables. Of course, our procedure add3numbers does not demonstrate this technique. We'll have another example that demonstrates local variables a little bit later on. But so let's discuss this enter instruction, and this is what it does. Basically, it does push EBP, it does move EBP ESP, and it subtracts from ESP the first parameter that we use with this instruction, some kind of number of bytes. So we subtract value from ESP, and the result of this subtraction is this allocation of space for local variables on the stack. And then later on, of course, as we execute our procedure, we're free to continue using the stack. So there may be some more things saved, like we may want to preserve some registers, restore these registers, essentially use the rest of the stack as we need during the execution of our procedure. So that's why we say that we can preserve registers right after the local variables on the stack. But of course, local variables are not accessed through ESP, because once again, ESP is kind of free to move up and down here as we preserve and restore things on the stack. But local variables, of course, are accessed through EBP. So now we use EBP to say, okay, if we move in the direction of like give negative displacement to EBP, we will be finding our local variables on the stack, because EBP, when used in indirect memory access as a base register, will give us access to the stack memory segment, and we can find local variables. In our example, we were finding here not negative but positive displacements, positive offsets. So of course, what this did for us was that we were accessing our procedure parameters. Okay, so this is what we did with these operands using EBP as base register. So this was essentially giving us access to our procedure parameters. But if we want to support some local variables here, we could do this, and enter instruction could do something like this for us, because it would automatically execute this type of entry into our procedure with an option to subtract value from ESP to provide space for local variables instantly upon entry into procedure. The corresponding counterpart, the leave command, translates to move ESP EBP. So basically, you really don't need to worry about any of the stuff right here that we've organized with respect to our local procedure organization, local variables, anything else we did. We just instantly say, let's jump back to the state where ESP and EBP are pointing to the same place, with old EBP right at the top. So this first instruction brings us back to this state right here. Right, so now we're in this state of the stack, and then we pop EBP. Then, of course, after popping the EBP, we're moving right back to this state, which is pretty much the beginning of entry into our procedure, so that we now have return address right there, and return instruction is commonly executed following the leave instruction. Right, so after leave, we typically just say return. Okay, because we're now ready to return, and we return to the calling procedure. Of course, the return instruction, like we have it here already, we'd be jumping right back to the next instruction after the instruction. I'm sorry, this is not correct place. This add3numbers that we used in our demonstration. So our return instruction, of course, will be taking us back to this instruction right here, where we maintain our stack after calling C style, using C style calling convention, where we need to adjust the stack pointer to remove the procedure arguments from the stack. And that's what this add instruction does. So basically at this stage we're back to the initial state of the stack. So this is an overview of these two commands, enter and leave, which are available. Of course, our procedures are kind of tiny and small, and they may not require using all sorts of additional commands that are available with respect to maintenance of the procedure organization. And just in summary, to mention, the second argument of enter instruction is something that's called a nesting level operand, which gives an ability for the procedure to determine the number of stack frame pointers that have been copied into existing memory already. So this is something that we really are not going to discuss right here, and if you use 0, this will be pretty much what you would use in the situation with just writing a simple code like this.